Hi, welcome to Algebra 1. This is Module 1, Topic 1, Linear Equations. This is our review packet. And we are going to start with 1. Again, please don't just watch this video all the way through. Do the problems first, and then see where, if you get stuck, then look at the videos, okay? Or if you have no idea what to do, then look at the video, pause it, then do it by yourself. Okay, that's a good way to study. All right, so number 1. Mila collects candles. The table shows how many candles she started with and how many she has after 4 weeks. Here's our table. We have time in weeks, we have number of candles, and we can see the information here. After 4 weeks, she has 21 candles. And A says, calculate the number of candles Mila collects per week. So this is basically asking for the slope. So we're going to go with slope. There's a lot of different ways to do this, but this is the way I like to do it. This is our y, so this are just the difference in y. So we're going from 21 to 5. So if we go 21 minus 5, that is going to give us 16. And over here, for the x's, from 0 weeks to 4 weeks, that is a 4-week difference. So it's 4 minus 0. I'm just showing you the work here. That's what is going on in my head. And that would give us 4. So our slope, we call it m, is equal to the rise over the run. So the rise is the y. So it's going to be 16 over 4. So over the course of 4 weeks, she gets 16 more candles, because remember, she starts with 5. So which means that per week, she's getting 16 divided by 4, which is going to be 4 candles per week. All right. And then if you can see right here, it's the candles per week. Okay, and when you see things like per week, you know, okay, we're talking about slope. All right, next one. Define the variables for the amount of candles Mila collects over the weeks. So our variables, we have like our x and our y. You don't have to use x and y. You can use w for weeks and c for candles. But we do need to define them. So I'm going to use w for weeks. And so when it says define them, it means tell us what it means. So W is the number of weeks. And then C is going to be for our candles. This is the number of candles. Candles collected. All right. And it says writing equations. So we define our variables. We're going to write our equation. Remember, W is like our X, C is our Y. We're going to write an equation. So this is very much, we have the slope, we have the y-intercept right here, because we know at 0 weeks, it is the number of candles. So again, I'm going to make yellow be our slope, our y-intercept. So this 5 is going to be our, what is it called? Our y-intercept, okay, because this is 0, 5. Okay, at 0 weeks. So we know y equals, so y is going to be our c. The number of candles is equal to the slope, which is 4 times the number of weeks plus our initial amount. How much did we start with? 5. Okay. So again, our slope is going to be our 4. So our 4 is right here that you can see. And our y-intercept is this 5 right here. Maybe I can make it a little smaller so we can see it all together at once. Let's go. There we go. So y is going to be our, y-intercept is going to be our plus 5 right here. That's where we're getting all this information from. And then we're going to use this equation to do D. It says use the equation from part C to determine the number of weeks, number of candles Mila has after 3 weeks. So we're going to just plug this in. I know a lot of you guys probably do this in your head. You calculate it out just by using a calculator. Well, I'm going to show you how to do this just by using. So this is after 3 weeks. So remember, the 3 weeks is like our X. We're going to plug that in for this W right here. Is our independent variable. So C 4 times, instead of W, we're going to put in 3. So I'm going to put like parentheses like that, plus 5. Now we're just going to do the order of operations, right? Just to see what we do. Remember, we multiply first. So we're going to go 4 times 3, which is 12, plus the original 5 that she had, right? So that's going to be a total of 17. So 17 candles. So she's going to have 17 candles after 3 weeks. Again, we're going to do the same thing, but now we're going to determine how long it's going to take Mila to have 65. Now, 65 candles, I don't even know where we're going to put all that, right? So we have 65 candles. We're no longer talking about weeks. We want to find out how many weeks, right? So we're going to put 65 in for the C. So here's 65 equals 4W plus 5. All right, so we don't know how many weeks, so we're gonna now have to solve this equation. So let's go. So instead of plus 5, we're going to subtract 5 on both sides. Right? So we're doing the opposite because we're solving for W. Here we didn't have to do that because C was already solved for, and we just had numbers on the right-hand side, so we just had to use order of operations. Here the W is not W equals. We want it to be W equals, so that's what we got to do some work here, some algebra here. So 65 minus 5 is 60 is equal to 4W. Remember, our 5 minus 5 cancels out, becomes just 0. And then we're going to have 4 times W. So opposite of 4 times W, we're going to divide by 4. And so we have 4 goes into 60 15 times. Okay, so W is equal to 15. So that means it's going to take Mila 15 weeks to get 65 points. All right, that's it for number 1. We're going to try the same thing. So again, pause, try this out yourself. If you're like, I don't know if I got it, I just need to check this, please feel free to just look at it. Why is this not? Okay, this is too much. Let's go right here. So here we're talking about Elwin. Elwin bought a lot of golf balls at the beginning of the season. The table shows how many he has at the beginning, right here, 84 golf balls, and in the middle of the season, which is after 6 weeks, he had 66 balls. As you can see, he's losing his golf balls. Sad days. So again, it says calculate Elwin's average number of golf balls lost per week. So if we're seeing lost, I'm thinking we're probably going to subtract, right? So here we go. We got 66. We're going to find the difference in Y. So 66 minus 84. So we're going to be in the negatives for sure. So this is going to be negative 18. All right. And if we look over here, from 6 to 0, that is 6 weeks have passed by. So in 6 weeks, he's lost 18 golf balls, right? So we're going to calculate it out. Again, slope is M. So it's going to be 18, so it's the Y over the X, so 18 over 6. I should say negative 18 over 6. And negative 18 over 6 simplifies to 3. So he loses 3 golf balls per week. Yeah, maybe he's losing them in the trees or in the water. Hopefully not in the water, right? Or he just can't find it, right? So he's losing 3 golf balls per week. Now we're going to define the variables for the amount of golf balls and the number of weeks. So in this case, before I use W and C for the weeks and the candles, this time I'm going to just use X and Y, because a lot of people are just comfortable with X and Y as well. So I'll try that one this time. So here's my X, there's my Y. Remember, always X is our independent variable, and then Y is going to be our dependent variable, because time does not depend on the number of golf balls, but the total number of golf balls depends on, well, how many weeks have passed, right? That will define how many golf balls he's lost. So here we go. X, what is X? I like to use a colon. Some people like to use an equals. Either way is fine. X is going to be the number of weeks. And then Y is going to be our total number of golf balls. So total number of golf balls. All right, I think golf balls are 2 words, but that's fine. All right, so now we're going to write an equation. So y equals, we got our slope and we have our y-intercept, right? Just like how we did before. And then, so we know we have, so y equals m. What was our m? It was -3, because we're losing 3 golf balls per week. So x is our total number of weeks. And then plus, how many did we start with? How many do you have in the beginning? You had 84 in the beginning, right? So remember, our y-intercept is called b for the beginning. So again, we're going to just, here's our y-intercept. Here is our slope, just like that. And so right here, we're going to just plus 84 because we started out with 84. Okay, and there's our equation. And then use the equation to determine whether how much he has after 4 weeks. We know 4 weeks, remember weeks is talking about the x. So this is our x. So we're just going to plug it in for x. So y equals -3. Instead of x, we're going to put in 4. We're just substituting. Okay, just so that you can see this. Remember, our 4 weeks has to do with our x, which has to do, so we're just replacing, instead of this x, we're putting in the 4. And then let's do some order of operations, because y is already solved for. So -3 times 4 is going to be -12 plus 84. And we know -12 plus 84 is going to be 72. So y is equal to 72. So 70, that's going to be 72 golf balls. Okay, so he has 72 golf balls after 4 weeks. Which again makes sense because that's in between the 66 and the 84. So we know if 4 weeks is somewhere in between here, the number of golf balls is going to be somewhere in between 66 and 84. All right, just some, logical thinking here. So it says right here, so use the equation to determine how long it's going to take for him to have 24 golf balls left, right? So 24 golf balls, remember that's our y. So instead of our y, we're going to plug in, let's see if I can just do this. So instead of our y, we're going to plug in 24 equals -3x, because we don't know how many weeks. That's what we want to know. It says how long, right? Plus 84. Again, just like how we did over here on the left, we're going to get rid of the adding first. So instead of adding 84, we want to get rid of that part because we're like, that's how much we had in the beginning. So we're taking that out. And so basically we've lost how many balls? 24 minus 84, so that's going to be, we lost 60 balls, right? 60 golf balls, that's quite a bit. Make that be -60 is equal to -3x. And if we're losing them at a rate of 3 golf balls per week, how many weeks is that? So we're going to just divide that by -3, divide by, oops, it's not what we're going to do. Try that again. Do it. -3, there we go, divide by, oh, -3. Okay, guys, that's a -3. It does, I know it looks weird, but it's a negative. So x is equal to -60 divided by -3. And that would be 20. So this is going to be after 20 weeks. He's going to have, so he could play for quite some time, 20 weeks, and he still has 24 golf balls left. It's not doing that. All right, so that's the end of number 2, and we're going to go on now to number 3. That logically makes sense. So it looks like we have a graph here, and Xenia is selling earrings that she's made on Etsy. She's making some side money here. The number of earrings she sells can be modeled by the equation y equals 15x plus 10. So what it seems like, it says A is fill the table using the equation. I'm going to just do a little, I mean, you can plug these in and fill it out, or you can graph it, right? So it has a graph right here. So my y-intercept, what did I have my y-intercept was yellow, so I'm going to make it yellow. So my y-intercept right here is 10. So what I'm going to do is I'm just going to go right here. Let's make this yellow. And we're going to go right here at 10. There's 10 right there. On the y-axis, there's our y-intercept. I know that line crosses right here at the 10. And then it says that my slope is going to be 15. I believe 15 is orange. I made it. So not 15x, just 15. So what we're going to do is we're going to go, remember this is over 15 out over 1, right? If there's nothing there, it's over 1. We're going to go up to 25, and then so that's 10, and then 15, and then go over 1. So again, 10, and then 15, go over 1. All right, 10, 15. Always look at your units or the scale on the left. We're going by tens. So yeah, I know that 15 is going to be one of these boxes plus a half. All right, and so I'm going to just keep on doing that until I get to the end, because I know that I'm not going to be able to draw a very straight line here. So this should be a straight line here. Let me see if I can get a line going on. Oh, here we go. Let's drag this over. Let's let me drag this over. There we go. Oh, that works. There we go. Just like that. All right. So now we have our line. Oh, this one. Okay. So now we have our line. That kind of works out. And now we're going to use the table, this graph to figure out the numbers in this table. So if you look right here, 0 days. How many earrings did she sell? Well, she's already sold 10, right? That's just our y-intercept right here. So this is 10. All right, after 3 days, I'm going to go to 3 days. And how much is that? Remember, that was up at halfway mark. So that's going to be between 50 and 60. So that's 55. So this is how graphs are really useful. That's the table 55. Try this one more time. 55. All right. And then, okay, now this is backwards. So now we know that we sold 85 earrings. And how many days was that? So let's go to 85. That's going to be right here. And it's right here at 5 days. And then at 1:30, again, we're going to go all the way to 1:30. And we're like, oh, phew, barely made it. We got 8 days right there. Okay. And so that's an easy way to figure that out. I mean, you did use the equation, we graphed it, right? And then we were able to, using the graph, we were able to fill out this table. It's not really hard. And B, we graphed the points on from the table. Okay, technically we already, we already did this. We graphed it. So that's fine because we already know how to do that. Connect the points if you think it is appropriate to do so for this problem. I suppose, yeah, I mean, yes, because we can do all these other points too, because she could sell 16 or 17 or 18. Technically, they should be small dots because you can't have like 16.5, but it's fine. We're going to just draw them. And what is the slope? We already know the slope. Do we need to calculate it out? Do we have to do what we did before and go 55 minus 10 and then 3 minus 0? No, it's already given to you. It's 15, right? So the slope is 15. If it's already given to you, you don't need to calculate it out. And what does it mean in the terms of this problem situation? So what does the 15 mean? She is selling 15 earrings per day. Okay. Remember, we're using the word per. So we'll say she sells 15 earrings. That's quite a bit. She's like very busy per day. Okay, we got the context. There we go. If you want to look at here, it always tells you the X and the Y. So remember, it's the change of Y first. So it's going to be, she sells 15 earrings per day. If this said weeks, then it would be per week, right? What is a y-intercept? Remember, our y-intercept is this 10 right here, which is this 10. So an easy way to just look at it, it says, so 0 days, 10 earrings, right? So after 0 days, she sold 10 earrings. What does that mean? So let's try this out. I'm just going to write it first. So this is the y-intercept. Sorry. So remember, this is at the start, at the beginning, or you can say after 0 days. But I like to say at the beginning. At the beginning. She already sold. So these are things that already happened. She already, I don't know why there's an extra. Already sold 10 earrings. Maybe she already sold them to her sister. She already sold them to her friends, whatever it was. But before she started this whole thing, she's already sold 10. Right? Maybe that's why she decided to go into Etsy. Who knows? Right? Done. Okay, so we stated what the y-intercept is, and this is a problem. This is what it means. Okay, and where's the 0? At the beginning. Okay, so this, let me see, make that pink. So this 0 is found here at the beginning. That goes together. And then I'll make green. And she sold 10. Oh, I don't see that very well. Let's try a different one. Let's try this. So 10 earrings right here, that is this 10. So remember, both numbers have to be represented in percentages. All right, let's try this one more time. Again, you try this yourself and then press play. So pause right now. All right. So Amaru decides to walk every day. He recorded how many he's already walked. So he's already walked a certain number of miles already. The total distance he walks can be modeled by the equation y equals 4x plus 5. So it looks like we're starting at this plus 5. So he's already walked 5 miles, right, before he starts this recording thing. So I look over on the side, and it looks like we're going by, this is 4, this is 8. So halfway between 4 and 8 is 6. So I know this is 6. So 5 must be halfway up that little box. Okay. So there's 5, and we're going to go up 4. So my slope is 4. I'm going to use my orange. And then we're going to go 4. So 1, 2, 3, 4, and or 1. So we're going to be halfway up. So again, each half of a box is going to equal to 1. So I'm going to go up 1 box, 2 box, like halfway in between. Oop, that's not it. I forgot to go over 1. There we go. Up 1, 2, 3, 4. Up to 4. Up to 4. Another way to think about it is that this is 25. 25 plus 4 is 29. So I'm going to look for 29 and then go over 1. And then this is going to be 29. Did I say 21? 29. 29 plus 4 is going to be 33. So I'm going to go up to 33. Just like that. I can't go anymore because it would be like up here. Okay, so now we're going to draw our line just like how we did before. No, this is not that good. Let's try to make it. All right, so you're going to draw your line. It's good to use a ruler. In this. Okay. Apparently I cannot talk and do that at the same time. So, okay, there we go. So assume that those are going over the points. I'm having a little trouble doing that. It's not doing that exactly for me, but it'll work. It'll figure itself out. Okay, that's fine. All right, so now that we have that equation, that line drawn, we're going to slowly go down here because we need this information. So if we've walked 5 miles, we've already walked 5 miles. Well, that was at 0. We already started with that. So that's going to be at times 0. And then after, for 13 miles, so there's 12, here's 13. That is going to be 2 days. It took 2 days. And now we're already at 13 miles. Good job. So 6. So this is going to be, now we know the days. So we're going to go to 6, and we're going to go all the way up here and see how many miles we've walked. So it's going to be 1 above 28, which is 29. 29 miles. It's a long time. And after 8 days, we're going to go all the way up here and go all the way across. It's going to be 37. So 37 miles. So after 8 days, he's walked 37 miles. That's quite a bit. All right. And okay, we graph the points. What is the slope? Okay, again, the slope is going to be 4. We don't need to calculate it out because it's already given to us. So slope is equal to 4. And what does it mean? It means Amaru walks 4 miles. Remember, 4 miles. per how many? Per day. So you need to say something about per or each or every. So walks 4 miles every day, per day, something like that. You can't just say Amara walks 4 miles because that's not a rate. That's not the slope. Okay, slope is a rate, how much he's doing something per every day. And what is the y-intercept? Again, remember the y-intercept is shown in two different places. Right here, the 5 or this 0, 5. Okay, either one tells you what the y-intercept is, which means that our y-intercept is going to be 0, 5. So you can say before he starts recording, right, because that's the 0. Before he starts recording, he's already walked 5 minutes. Okay, there we go. And see, because it says he records how many he's already walked. So we're recording how many he's already walked. So again, 0 is found right here. Where is the 0 found in our statement? Before he starts recording. All right, and then where's the 5? The already walking 5 miles. Both parts are already addressed. Happy days. All right. Now 5 through 10 are the same thing. They're just graphing. Make sure you have your ruler, and we're going to have our right here. Notice this is in slope-intercept form, so it gives us two things. It gives us our slope and the y-intercept, not the x-intercept, the y-intercept. All right, let's go number 5. So again, number 5 is going to be our y-intercept. We start with the y-intercept, which is the beginning. So go on our y-axis, go to 5. So there we go, 5 right there. And then our 7/3, that is going to be our slope. So remember 7, remember it's rise over run. So that means the 7 is going to go up, positive, and 3 is positive as well. So it's going to go to the right. Rise, the top tells us the up and down number. The run tells us the left and right number. Okay. And if they're positive, that means they're going to go up. If it's on the bottom, it's going to go to the right. So you're right. Anyways, doesn't matter. So you're right. And so if you notice here, I can't go up 7, so I'm gonna go the opposite way. So I'm gonna go, instead of going up 7, I'm gonna go down 7. Everything's gonna be reversed. So I'm gonna go down 7. So there's 5, 6, 7, and then now instead of going right 3, I'm gonna go left 3. 1, 2, 3. And I'm doing that because I can't, or normally I would go up 7, right 3, and my point would be up here somewhere. But I can't do that, so I'm going the exact opposite. Do you see how it would make this like line like this? All right, so I can't do any more points. These are the only 2 points I can actually do on this graph accurately, and then I'm going to draw my line. Make sure that your line, you'd use what is it called? A ruler. Ooh, let's see if I can do this. I don't normally use this. Oh, not bad. So see how it goes through both points like that? That's what we want. Okay, we want it to go through both points. Okay, there we go. Just like that. So notice this is a positive slope, just like how this is a positive. So we're good to go. It crosses right here at 5. It's good day. All right, number 6. Notice right here, we don't have any number on the bottom. If there's no number on the bottom, what is it? It's a 1, right? Why is it a 1? Because 4 divided by 1 is just 4. That's why it's divided by 1. That's why we couldn't say 2, because 4 divided by 2 is 2. You see how it doesn't stay as 4. So here we go. Let's try this again. So our slope is, what do I mean? Y-intercept is 3. So we're going to go right here on the y-axis at 3. Then we're going to do our slope. Our slope is 4/1. So this is going to be 4 is positive, so it's going to be up 4 and then to the right 1. So we're going to go up 4, 1, 2, 3. Ooh, I can't go up 4. Right, well, it'll be like right about there. Let's do the exact opposite and actually be on this coordinate plane. So we're going to go down 4 and then to the left 1. Okay, down 4, 1, 2, 3, 4, and then to the left. So see, it's going to make that line just like this. It is a very steep slope. Sorry, I can't just do it right on the line already. It's just being very, very fickle. Okay, there we go. So we got to make sure that it goes through all the points. There it goes, just like that. All right. Again, positive slope, and this is a positive slope right here. 4 is positive, line is positive. All right. Again, -5 is our y-intercept. We're going to go down to -5 on the y-axis. Our slope is, now this time we have a negative number, -3/2. So -3/2. So from here, so the negative either goes to the top or the bottom. We don't do it for both. If we do it for both, they cancel out, and it's gonna be sad days. So again, I'm gonna bring that negative to the top. So I'm gonna go down 3. Actually, I can't go down 3, right? So I'm just not gonna do down 3. I'm gonna do up 3, which means my negative is gonna be on the bottom. So and then instead of going right 2, it's gonna be left 2 because it's -2. I'm gonna go to left 2. I'm going to go up 3, 1, 2, 3, and then left 2. Notice now making a negative slope, right? All my points are going here to the left. Can't go down this way, and see it's going to give that negative slope right there. All right, so I'm going to just bring this over. Because it should go through all the points. And here we go. Again, please pause. Do this yourself. Don't just brainlessly, mindlessly just copy things down. You have to actually do them. Okay, again on the y-axis, you're going to -2. Your slope is going to be -1/2, so you know it's going to be in the negative direction. So we're going to go, this time I'm gonna just put it to the top. So instead of going up 1, it's going to be down 1, and then 2 to the right. Okay, so we're going to go down 1 and 2 to the right. Then down 1, 2 to the right, down 1, 2 to the right. Or let's do, because we don't have the left hand side. So we're going to go the exact opposite. So up 1, 2 to the left. Notice it follows the pattern. So we have this line that goes just like that. And let me get my line going. Right around there. And here's my line. Oh, not that one. All right. So notice this is a negative slope, and it's the negative slope of -1/2. Okay, last two. Here, notice we have no y-intercept, right? Which means that, well, there is a y-intercept, you just can't see it. If there's nothing there, like -3x plus what will give you a -3x. Has to be 0, right? Yeah, nothing to it. Okay, so now our y-intercept is going to be at 0. Okay, this doesn't happen often, but it does every now and then. So it's going to be right here at the origin. That's where it's going to cross the y-axis. And then our slope, again, if it's just like a negative, like an integer, remember this is over 1. So one time we like to have fractions in there, right? And here we go. So it's -3, we're going to go down 3. And then 1 is positive, so we're going to go to the right. And so from here, from the y-intercept, we're going to go down 3 and then 1 to the right. Down 3, 1 to the right. Do the exact opposite and go up 3 and then 1 to the left. And then up 3, 1 to the left. And see, we got our negative slope right here. I'm going to make fine line. Okay, and move it. There we go, just like that. going right through the origin. Last one, y-intercept is going to be at 1. So we're again, remember the y-axis, y-intercept, so it's on the y-axis. And then our slope is going to be 3. We have no other number there, so it's going to be 3 over 1. And let's graph this guy. So again, this is 3 is positive, so we're going to go up 3 and 1 to the right. Right, up 3, 1 to the right. Notice it makes a positive slope. We're going to go down 3 and then 1 to the left. A lot of people forget this one. You count that as well. So it's 1, 2, 3, and then 1 to the left. And there we go. That was the last one for slope-intercept form. Oh, did I actually do it? Ish. I'm not sure. Over just slightly. Put a bit on that one. There we go. Okay. So there's graphing with slope-intercept form. All right. Now this one is going to be a little bit different. Notice that we have it's in a different form. This is a point slope form. So again, our point slope form looks like this. So y minus y1 equals m times x minus x1. Right. This is point slope form. All right. And the reason why it's point slope form because it gives us two things: point and a slope. So let's go. Let's figure this out. Our point we're going to make pink. And so if you notice right here, our x1 is this x1 right here. Notice there's already a minus there, so we're not going to take that part. Our y is going to be with the other y. We'll make that green. So this y1 is going to be green. Okay, so there's our point. So our point is going to be, let's see, I think that's pink. So x is 2, and then y is going to be 2. All right, so there's our point, and our slope is, again, right here, -1. Okay, so let's go to the point, -2, 3. So -2, 3 is, or 2, 3, sorry about that. So this is going to be a 2 and then up 3. For me, I like to think of it as it's opposite of what I'm seeing. So if this is a -2, then my x is going to be a +2. This is a -3, so this can be a +3. The reason why that is because normally this stems from the slope formula. And so we're looking at the differences. So this is normally supposed to be y minus. So this minus has nothing to do with the y. Okay. And so here we go. So now that we have a point, now we're going to use our slope. So this is going to be 1/2. Remember, you're going to start at your point. You're going to go up 1 and then to the right 2. Up 1 to the right 2. Up 1 to the right 2. Again, this is up 1 and then to the right 2. Or down 1 to the left 2. Down 1 to the left 2. All right. And we're going to continue that pattern on all the way through. Just draw your line. All right. It's about not bad, not bad. All right. Going through all the points like that. Again, we're going to do the same thing here. If you notice, okay, let's make our point right here. There's our point, and we're going to use, so our x is going to be, remember this is already a minus, so our x is just 5. There's my point. So 5. And then our y is going to be, notice this is a +4, right? So remember, it's opposite of what we're saying. It's not supposed to be a plus, should be a minus. So what this actually is it's a y minus a -4, right? So the y is supposed to be a -4, but normally we don't write minus negative. What do we write? We write that as just a plus. So it's actually a hidden -4 in there, okay? Because this should be y minus. The only reason why that's a plus is because it was actually supposed to be negative. So here we go. There's your negative right there. And again, our slope is the number in front. See, our m is the number in front of the parentheses, and which is our -2. So again, let's plot in 5, -4. So we're going to go to +5 and then down 4, -4. That's our point. And then we're going to use our slope. Remember, this is negative 2 over 1. So it's going to be 2 down and then 1 to the right. We're going to go 2 down and 1 to the right. Notice how it makes a negative slope. Or we're going to go up this way. And then we're going to just draw our line. Okay, there we go. Just like that. Okay, again, please practice. If you get stuck, then go back to this. Okay, I will just quickly do these and we'll finish the last two pretty soon. All right, again, our point is going to be, see, this is positive 6. This is going to be negative 6 for x. Then my y is going to be negative 2. It's opposite of that, so we got negative 2. All right, there's our point. Our slope is going to be 2/3. It's already in a fraction. That's good. So we're going to go to negative 6, negative 2. This is our point. And from that point, we're going to go 2 up and 3 to the right. So 2 up, 3 to the right. 2 up, 3 to the right. 2 up, 3 to the right. And that's about as far as I can go. And we just draw a line. The more you practice this, the easier it's going to become. There we go. All right, and the next one. That is again, this is already a minus, so we're going to just take the 4. And so that's going to be, the point is 4. And our y is going to be 5. Right, so our point is going to be 4, 5. We're going to go to the right 4 and then up 5. There's our point right there. And then our slope is going to be negative 2/3, which means we're going to go the negative. I'm just bringing that to the top. So we're going to go down 2 and then to the right 3. Remember, the negative only goes to one of the numbers. So down 2, right 3. And we can't do that again. So we can go up 2, left 3. It's just right here in this corner. Remember, make sure you have your arrows going through all the points. That'll be important. Your line going through all the points, and then make sure you have arrows on there because this does continue on forever. All right, we don't want to draw that, so we just draw the arrows. All right, and our last two right here. And so, again, it's going to be our y coordinate, or sorry, x coordinate. So 3, comma. And this is going to be this is plus 3. So remember, it's opposite of that. So it's going to be minus 3, opposite of what we're seeing. So this is going to be 3, negative 3. So here's 3, negative 3, right here at the intersection. And then we're going to do our slope. It's 4. So remember our slope, remember there's no number here, so it's over 1. That means it's going to be up 4 and then to the right 1. So up 4 to the right 1. Up 4 to the right 1. Can't do it anymore. I can go the exact opposite way. So down 4 and then to the left 1. Right? It's like that. Anytime you have your lines and they don't look like they match up, it means that you need to make better lines. No, you need to check your slope. You might have counted incorrectly. I've seen that happen a lot. Okay. Last one. We're gonna go, so our x coordinate is with the x, so it's 2. And y coordinate is going to be 1. This is already a minus 1, so we're just taking the 1. So 2, 1. So here's 2 and over 1. That's our starting point right here, 2, 1. And then our slope is going to be negative 6/5, which means that we're going to go, the negative I'm going to put to the top, so it's going to be down 6 and then to the right 5. So down 6 and then to the right 5, which is going to be at 7. Or up 6, So this is going to be 5, 6, and then to the left 5. 2, 3, 4, 5. Okay. Again, one thing to look at it, it's down, so it's down 6, then to the right 5. Okay. And let's draw that line. Probably like that. Let's move it over. There we go. That was the last of those. All right, so now we know how to graph in point slope form. We're given point slope form. And this is our last ones. Okay, so 17 and 18. Let's take a look here. Let me just do like right here. So it says make a scatter plot on the grid. And so if you look right here, we have the number of minutes and the amount spent. So looks like the more we spend time in there, the more money we spend in general. So let's try this out. So we're plotting these. So after 10 minutes is 20 bucks. So here I'm looking at the bottom here. Looks like each of these is $10 or minutes. Okay, I'm just gonna write minutes here. And it's gonna be dollars. It's gonna help me keep things straight. So after 10 minutes, it's gonna be 20 bucks that I'm spending. Right? To 20, 30. So after 20 minutes, somebody spent 30 bucks. After 30 minutes, they spent 40 bucks. Ooh, this looks kind of linear. The 40 minutes is also 40 bucks. Okay. Take it back. It's not linear anymore, but it's linear-ish. Right? 60 minutes is 50 bucks. So 60 minutes is 50 bucks. And then 130 minutes is 90 bucks. So 130 is all the way at the end. 90 bucks is all the way at the corner. All right. So, we made a scatter plot. Done. B is draw a line of best fit for the data and write the equation for the line drawn. So what I'm going to do is I'm going to first, we're going to, remember we, oh, this is so good. You have to draw an oval around all the data points. It's kind of hard to do on a computer. I'm going to start from the bottom first. There, that's better. Okay, so we grabbed all of them. So so our line is going to be like this, somewhere in that direction. So I'm going to kind of use this to kind of edit my line. So notice how all the points are on the top. So I don't really want that. So I'm going to move this. So you would just use your ruler. I'm going to use, so it's going to be maybe like this. I have some points on the top, some points on the bottom. Kind of just, so all of them are kind of close by. There we go. I'm going to use that as my point. So now, if you see here, I need to write an equation. So you can use one of two. You could either use a point slope form or the slope-intercept form. The only time you would want to use a slope-intercept form is if you have like a nice y-intercept. And if you look here, it looks like it's 20, but it's a little below 20. But I don't know where. Could be 19 or 18. So I'm going to just use point slope form. Okay. So in which case, either way, I still need 2 points on the line because I need to find the slope. So I'm going to find 2 points that are intersect pretty well. Actually, this one intersects right at the point. It doesn't have to be one of these points, but it just turns out to be a good point. And then don't get one too close. One kind of further away, like at a nice intersection. My other point, it looks like it's right here. Okay, so you're going to just take a look. Okay, so now that I have 2 points, I'm going to find the slope. And how do I find the slope? Remember the rise over the run. So I'm going to go all the way up to this, see how it's with this point, and I'm going to go to the right. It's like directions. How far up do I have to go? So I start at 30 and then go all the way up to 90, which means that's 60. I just went up 60 bucks, right? So each box is worth 10. So 10, 20, 30, 40, 50, 60. Okay, another way to do it. And each one of these is also worth 10, right? You gotta look at your scale. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And just to check, I started at 20 and I ended up at 120. Well, that difference is 100. Okay, so now My slope then is going to be rise over run, so 60 over 100, right? I can make that, if you use a calculator, you can calculate that out. It's going to be 0.6, okay? Or you can just put 6 over 10 or 60 over 100. Either way is fine. I'm just going to put 0.6. Then again, I'm not using the y-intercept, so I'm going to be using a point. So I'm going to use the bottom point right here. You can use the top one. It doesn't really matter. I'm going to just stick with smaller numbers. So I'm going to stick with this one. So this is going to be 20 and my y is 30, 20, 30. So now I'm going to write the equation down. Here we go. So y equal, well, let's make this better. So y might not y equals y minus, because I'm using point slope form, remember? Y minus y1. Y1, this is the y coordinate, so it's 30, equals slope, which is 0.6. So we're going to go 0.6 parentheses x minus, and my x1, which is 20. There it goes. So I got all numbers in here. I got my y, I got my slope, and I got my x. There's a go. Line of best fit. All right. Determine whether the association is positive or negative, and then describe the relationship of the amount spent as people spend longer time in the store. So if you look right here, well, this is a positive slope, so it's going to be a positive association, right? So the longer they spend in the store, what are they doing? Spending more money, okay? So I'm going to write positive association. And then the longer people spend in the store, the longer people, not spend, the longer people are at the store, because spend might be confusing, are at the store, the more people spend. We'll just put dollars there just to, because you're spending time, but this one you're spending more money. Okay. And then interpret the slope and the y-intercept of your line. Ooh, we don't have a y-intercept, but we can figure it out. Okay. So interpret the slope. So we know the slope is 0.6, right? So m is equal to 0.6. So remember, I said to look at the table. So it means they're spending $0.6 per minute. Okay. So we're using those numbers right there. So those units right there. So basically, what is $0.6? They're spending 60 cents. So this is going to be 60 cents. 60 cents per minute. There's context right there. Every minute you spend in there, you're spending 60 more cents. I think that makes sense. Well, I don't know how true this is. This is for this particular store. All right, and then we also need the y-intercept. We don't have the y-intercept, so what do we do? So remember, b is our y-intercept. We do have it in point slope form, and we know it's going to be like 19, 18, something like that. So this is what we're going to do. We're going to use this and change it to slope-intercept form. Okay, so we're going to just copy this down. Y minus 30 equals 0.6 times x minus 20. All right, first things first, we're going to just distribute. Okay, so y minus 30. I'm going to copy that down because I'm not using that part yet. And so I'm going to go 0.6 times x is just 0.6x. Let's do this guy right here. And then 0.6 times 20 is going to be, let's see here, 0.6 times 20 is 12. So minus 12. Okay, because there's that minus there. So 0.6 times 20 is going to be 12. And then last step, you see how we have this minus 30? Can't have that. Gotta get rid of that because we want slope-intercept form. We're just going to add 30 to both sides. Why do we add 30? Ooh. Why do we add 30? because it's subtracting 30, we're doing the opposite of that. We did talked about earlier today, or earlier in this video. So here that cancels out, we get y equals 0.6x, and then 30 minus 12 or negative 12 plus 30, either way, it's going to be plus 18. What do you notice? I told you it was going to be something like that, right? So our 18 is going to be our b. So b is, you can say 18, or we'll say 0, 18. That's going to be our y-intercept, which, look, see, I told you, it's going to be about there. And then what does that mean? So remember, we have to represent both things. It kind of doesn't really make sense, and usually with scatter plots, y-intercept doesn't really have much meaning. But in this context, if you spend 0 minutes in the store, you spend $18. You don't even spend any time. Maybe it's online shopping. Who knows? If you spend 0 minutes in the store, you spend $18 from the get-go. Wow. Okay. So again, usually for scatter plots, the y-intercept usually does not have much meaning. It's usually the stuff in between that would have more meaning. Let's try this out. The last one, use the equation of the line from part B. Let's see, this one right here. I guess we can use the slope-intercept form now that we have that. To predict the amount of money spent if they spent 55 minutes in the store. I'm going to use the slope-intercept form just because we have it. It's already solved for y. Because this y, remember, this 55 is our x. So, because x is talking about the number of minutes, right? So y is equal to 0.6. Instead of x, we're going to put in 55 plus 18. And so y is equal to, calculator. I don't know what 0.6 of 18 of 55 is. Okay, so let's go. 0.6 times 55. 33. Look at that. So 33 plus 18. So y is equal to 40, 51. You spend 55 minutes, they're going to spend $51. So they're going to spend $51. Okay. All right. Let's try 18 again. Try this by yourself. I'm assuming you've done it. And now you have a question and you're going to see. All right. So this is kind of talking about the number of minutes playing, the number of points earned. It looks like the more you play, the more you earn, right? That makes sense. So after 1 minute, it's going to be 15. So notice it's going by 10, so 15 can be halfway between. 2 minutes is 49 points, so 2 minutes, 49, so it's like right underneath the 50. And then 3 is 53 points, so 53, a little less than half. And 5 is 79 points, so 5, 79, so right underneath. And then 6 is 81, 6, 81, so right above. And then 9 minutes is going to be 87. 9 minutes, 87, so more than halfway, so probably somewhere around there. All right, ooh. This looks a little bit not as linear, right? But that's how grid games are sometimes, right? So let's try. Remember, we're going to do this oval, make sure we're capturing the whole thing. Oh, come on. Okay, there we go. And we're going to draw our line. So we should capture probably about like half of it. That was not that great. Let me just do some shifting here. So it's gonna be a little higher for me. I'm gonna be like, maybe like this. Okay, honestly, if you want to kind of fudge it, you can be like, oh, let's put exactly the y-intercept exactly at 20, right? You can do it that way, but just make sure that it's about that it should make sense. Like I wouldn't do this. Oh, let's make it at 60. I think that's a good idea. Do you see how it's like none of the points or above it even, like that's not a good line. So it should be about. Okay. And so let's make it about there. We got 4 points up there, but I don't think we're gonna get any better than this one. All right, so let's take a look here. That doesn't look very fun. Okay, when you go to statistics, it's not going to be like that. You're gonna actually be more accurate about it. But this is, this is about it. Okay, now again, what are we gonna do? We're gonna take 2 points. All right, because we still got to find the slope. So I know I have one right at 20, right? I'm gonna just use that one. I just need another one. I don't have any other good ones. None. Zero. Okay. What happens? You can do one of two things. You can move it, or it's not a very ethical way of doing it. But I would get one that's really close. Like this one right here is like looks like it's right at half. See, this is what happens when I don't use when I'm just trying to like fudge it. It's bad things happen. All right. So now I have my 2 points. This is going to be right at half right here. So now I'm going to find my slope. So I'm going to go up to here. So this is like 10, 20, 30, 40, 45. So, and then we're going to go to the right. Okay, that's really wobbly. It goes from 0 to 5. So that's going to be 5. See how this goes? All right. So my slope is going to be 45 over, so rise over run, over 5. Oh, look, but it's nice numbers. So 45 divided by 5, that's going to be 9. So my slope is 9. So again, we're going to write the equation. So y equals, well, actually, let me change the color of that. So y equals my slope, which is 9, x. Now, my y-intercept is a 20, right? So plus, all right. My y-intercept is right there. All right, let's go. Made the equation. See how simple that was? Okay, association. It's a positive or negative. And it says describe the relationship of the number of points earned as people spend more time playing the game. So as people spend more time, so this is number of minutes, right? This is going to be the points. I'm getting these from up here, right? So the more they play, the more they earn, right? What is that called? So that is a positive association. Positive association. All right. And then, so what is that going to be? The more they play, the more points they earn. All right, so interpret the slope and the y-intercept of your line. This time we do have the slope and the y-intercept. So here we go. Slope is m equals 9. So again, that's going to be 9. What's our rise? So 9 points per minute of playing. So 9 points per minute. And then our B is going to be, what is it? Our 20. So that's going to be 0, 20, right? This 20 right here. And that's going to be 20. They start with. So before you even play, you start with a certain number of points because they start with 20 points. Right? So the 0 is right here, they start, and then 20 is the 20 points. Now we're going to use our equation, y equals 9x plus 20, to figure out right here how much points they would get if they spend 7 minutes playing the game. About, right? It's not going to be exact. This is just to predict. So again, so this is 7 minutes is our x. So we're going to go y equals 9. Instead of x, we're going to put in 7 plus, what is it, 20. Okay. So this is always, these are just predictions. We're saying, you know, if you play about 7 minutes, you're going to get about this many points. Let's do some math. So y equals 9 times 3, which is 9 times 7, which is 63, plus 20. Y equals 63 plus 20, which would be 83. Okay, so 83 points. We're estimating that that's, if we play 7 minutes, they're going to have about 83 points. All right. If you want to see what the point slope form would look like if we did not have this, I can show you that. Okay, or you can just be done. This is just a little side note here. So again, if we were going to use a point slope form, I'm going to use this point right here. Let's make that orange. And I'm just going to show you because, you know, you might not get one that has a good minus. We can't draw one with that. So again, this is going to be 5 and 65. All right, point slope form would look like this. Y minus y1, which is the y coordinate, which is 65, equals m, so the slope, which is 9. Well, that's a weird looking 9, but that's fine. Times x minus x1, which is going to be this 5 right here. Okay, so that would be point slope form. And let me just change this to slope-intercept form because, you know, in case you're like, oh, I need to find out the y-intercept, or just, you know, like how we did here. And we're just going to do some math here. So y minus 65 is equal to, we're going to distribute. So this is going to be 9 times x, which is 9x. And this is going to be 9 times 5. So there's a minus here. So we're going to minus 9 times 5 is 45. All right. And then we're going to, how to get rid of this minus 65? Opposite of minus 65 is plus 65. Plus 65. And what do we get? What do we get? Cancels out, so we just get y is equal to 9x. Negative 45 plus 65 is going to be plus 20. What? See how it's the same thing? This is the same thing as that. That's what I'm telling you. Point slope form, slope-intercept form represent the same one. They look different, but essentially they are just the same. They just change the way it looks, right? Same thing. Right, have a good one. Enjoy. I'm going to pause this.